Okay, we're going to talk about scientific notation now. And in scientific notation, it's a short way of writing things so we don't have to write out all the numbers. This is considered scientific notation right here. This is in its condensed form. In its expanded form, what we do is we take this number up here, this is a positive 4. If it is a positive 4, that means we're going to go in the right direction 4 spaces. So I'm going to take this and I'm going to go over 4. 1, 2, 3, 4. So let me write that number here, 5.23. I'm going to go over 4. 1, 2, 3, 4. I'll need to fill those in, and I put my new decimal right there. So this number here is actually 52,300. That is your original number. This is that number in scientific notation. Now, notice on this one, in fact, I'll leave that one up for the moment, because on this one it's a positive exponent, so we went to the right. Let's do one with a negative exponent. We'll go 3.1 times 10 to the negative 5. So again, I'm going to write this number here, 3.1, and it's negative 5. Since it's negative, I'm going to go to the left 5 spaces. 1, 2, 3, 4, 5. I'll put my new decimal there, and I'll fill in the rest, all these zeros here. So this answer here is actually 0.000031. Here it is in scientific notation. There it is as just a plain old decimal. Now, we can switch these as well. If you're asked to convert a number to scientific notation, and let's use the number 486 million. A lot of zeros, and that's the reason why we use scientific notation, is so that we don't have to write out all these zeros. What we're going to do, with scientific notation, the number has to be between 1 and 10, and that sounds kind of weird. Basically what it is we take our first digit here, which is 4, and then I put a decimal right after it. If it's a 4 that's between 1 and 10, I'm good to go. So 4 point, and I put my decimal right there, and then I write the rest of the numbers all the way until I hit nothing but zeros. Everything else here is 0, so I stop. Okay, the object of scientific notation is to get rid of having to write all these zeros all the time. So I'm writing this 4.86 times, and we always do it times 10. Now, on this one, if the number is larger than 1, it's going to be a positive exponent. Okay? This one is larger than 1 because it's 486 million. That's a lot larger than 1. And here's your original decimal. I'm going to count how many spaces I move it over. 1, 2, 3, 4, 5, 6, 7, 8. So this one will be 4.8, and then I write that 8 right here. So the answer on this one will be 4.86 times 10 to the 8th power. Okay, that's how it is in scientific notation. This was the original number. Now let's look at a number that's really small. When we say really small, that's because it's got a decimal. So I've got 0.000048. Now let's not use 48 because I just used it there. So let's use a different number here. We'll use 3, 6. Okay. Now on this one, I'm writing the same thing. I write my first number, not a 0. We can't count the zeros, but my first number, which is 3. 3.6. And I just continue to write until there's nothing else, and there's nothing else. That's the end of my, nothing else but zeros, and that's all I've got there. So I write 3.6 times 10. Now I got to figure out how many spaces I moved to get this decimal to right there. So I moved 1, 2, 3, 4, 5, 6. I moved it over 6 spaces. So I know it's going to be a 6 there, but you see how this number is really small? The original number was less than 1. It's a really small number, so because of that I'm going to put a negative right here. So this number right here, 0.000036, is the same thing as 3.6 times 10 to the negative 6. Now let's do one more here. If I had you write the number 100,000, and I asked you to write it in scientific notation, I take the first number, which is a 1, I write that, and then I can write the decimal after it. But the problem with writing the decimal after it is everything else after that is zeros, so I don't write anything else. So just putting a 1 is sufficient. And I can go 1 times 10 to the, now here is my original decimal. I count how many spaces I moved it. 1, 2, 3, 4, 5. I write that here. This number, the original number 100,000, is larger than 1. So because of that, I leave this as a positive exponent. So my answer to this one is 1 times 10 to the 5th.